In a parallel circuit, the branch with the least resistance will always have the greatest current. What if the resistance was zero? That's what we call a short circuit. These are dangerous because large currents can damage components and heat wires, which has led to many house fires. Now for measuring voltage and current. You'll probably be familiar with the old analog voltmeters and ammeters, though these days we more often use multimeters, and these are what you'll be using when you come in to do experiments. The important thing to remember is that the ammeter measures the current through itself, so it must be connected in series with the current you want to measure. Ammeters are made with very low resistance so that they don't change the total resistance of their branch, and so don't affect the current that they're measuring. That's an ideal ammeter, of course. In reality, it's not possible to measure a current without changing it slightly. But that's a fundamental fact of measurement in physics. Note that you must make sure that students never connect an ammeter in parallel. This is no good for the ammeter, and it could turn out just the same as the short circuit case we just looked at. A voltmeter measures potential difference, which means it must be connected to two different points, and it gives the potential difference between them. Note that we can now see that if you connect both terminals to the same piece of wire, those terminals are at an equipotential, so of course the potential difference reading will be zero. When you connect the voltmeter between 2 points, it now provides an extra branch that current can flow along since it's in parallel with the circuit. To minimize the effect of this, voltmeters are made with very high resistance so that very little current gets diverted into their branch. They are effectively an open circuit, which means a circuit where zero current flows. But what will happen if the voltmeter is connected in series? It's not as bad as connecting the ammeter wrongly. It just means that it has such a high resistance that there'll be zero current, which is not as bad as a blown fuse or a flipped circuit breaker. Have you ever wondered what would happen, according to Ohm's law, if you simply connect the terminals of a power pack together with zero resistance? Would you get infinite current? The answer is no, because of internal resistance. All batteries and generators have internal resistance, due to resistance in their wires, also to chemical changes in batteries. So lemon batteries, for example, have very large internal resistance. We model any real voltage supply then as an ideal, which means zero resistance power supply, in series with a resistor. So you can imagine a little resistor actually sitting there inside the power supply box. It can be an interesting class project to measure internal resistance using the equation shown. But you have to make sure that there's always an external resistor in the circuit as well for anything except a lemon battery, because usually internal resistance is very low.